So welcome to our demo of medical robotics. My name is Daniel. I'm a researcher at the Hamlyn Centre. And before we started, I wanted to introduce you to the team. So Sam is also a researcher. He will be showing you how a surgeon operates a medical robot. And Seiyan and Christina will be helping us, making sure that everything runs smoothly and that you can watch this video without any problem. So yeah, we can start. So I'm sure that all of you have heard or seen robots at some point. They're everywhere in ads, movies, or I don't know. Even if you're lucky, you may have some robots at home, right? But maybe you haven't heard of medical robotics. And so medical robots, the concept is quite straightforward, right? It's robots that we use in medicine. But you may ask why they are important or why do we need them? So unfortunately, some of the procedures that we do nowadays, they are very difficult to perform with the tools that surgeons have. And this is a high risk to our health and make the procedure more difficult. And in other cases, we don't have the tools and to perform the procedure. So it's here when medical robotics and robotic devices can help and can assist the surgeon to make surgery safer and more accurate, and in turn provide better outcomes to the patient. And so to give you an idea of what robotics can do, this is just a tool that is used in neurosurgery. And this tool is used to remove tissue from our way, or to pick up something. But you know that the brain is very delicate, right? So we want to do this in a very accurate and soft manner. But sometimes the forces that we have to apply in order to not damage the tissue have to be very, very small, right? And it's here where robotics can actually help. And for instance, we could have a system that magnifies the perception of force, right? So with your hand, your bare hand, you can feel when you try to take something, right? But when it's very, very small, you might not feel it. So we can have a mechatronic system that magnifies and enhances the capabilities of our hands, and then allow us to feel something that before we couldn't. So it's pretty cool. But yeah, let's go to the robot that we will be showcasing today. That is called the Da Vinci, and this robot is the one that I have behind me. And as you can see, it has two arms that are moving at the moment. The red arm and on the right, and the green arm on the left. So these two arms are as if the surgeon would have his hands inside the patient, right? And to move them, our surgeon for a day, Sen, has a console with a bunch of handles, to be precise, that he moves to control these two arms. And you may be asking, how is he able to see what's going on inside, right? And that's why we use the third arm in the middle. It's a stereoscopic camera that provides Sen a 3D vision of what's going on inside. And so as you can see, he can observe everything that's going on inside our patient. And so if you think about it, it's like if the surgeon would be inside the patient with his eyes, his hands, and that with only like 3 tiny scars, as you can see right now. And So for the demonstration, as you can see already in the left of your image, we will be trying to operate the famous disease of the lemon, very common in the London area. So our surgeon, Sen, well, just remind he's a student. So probably some of the movements are not very orthodox, but he's trying to get access to the lemon tumor, and after that he will resect the tumor. So as you can see, the surgeon is still performing all the operations, so he's in control of doing everything. But if we think about the future, right? So how the procedure will be, like we just need to imagine like in movies, right? Like just like laying on a table and then some sort of automatic devices carry out the procedure, right? So for that future, we need to teach them the robot some stuff. And for instance, the lemon, in this case, is a static object, right? But when we operate in in a human, tissue due to breathing will move, and we have to teach the robot how to compensate for that movement in order to have an autonomous procedure. And so in those lines, we are doing some research in the center with very cool results that uh, help the robot to know when the tissue is moving and to move and shift with the breathing. And when we go, if we keep thinking about these autonomous procedures, we can think about, like for instance, like now Sen knows that he has to target the lemon, right? But Sen knows that he has what his target is. He's in control of everything. But when we leave this robot to operate on its own, we have to somehow teach the robot where to go and where not to go. It's kind of like in a video game, if you think about it. Like you're like playing in some parts of the map of your game, right? And you cannot go to other areas of the map, right? So in that area, our friend Sejan is doing some amazing research on how to teach a robot where to go, where not to go, and of course account for all the movement in tissue, because these no-go areas will change as the patient breathes. And you can see it's very cool, like all the controls that Sejan is working on at the moment. Of course, this is something that you will not have in an operating procedure where everything is already implemented. But in our case, since we're investigating with it, we keep control of everything. And we have here all the control boxes that are used to send the signal to the robot. And lately, another piece of research that we do in the center is, as you can see, all these tools are very stiff, right? But if you look at yourself, right, you look at your hands and you think of a surgeon's hands, they are soft and they are compliant and they're gentle with the tissue, or at least I hope that they are gentle when they perform surgery on us. But these ones are stiff and they are not compliant, and so our researchers, especially Sen, is now in the image, he's doing amazing work and amazing research in creating soft devices driven by pneumatics that can do as the surgeon hands. And I think this this is the end of our demo. So we can now answer some questions if you have them. And thank you for listening. So it seems that we have first question from Mohammed Abdelaziz about how much the robot cost. So this robot is about £2 million, which is of course high price to pay for a device, but it's not been in the market for about something like 20 years, and we are in that point of the technology in which other competitors are arriving, and hopefully we are at the point in which the price will start dropping and make it more accessible to more hospitals. So as we were saying, there are many different ways in which we can improve the robot. Basically, this robot, what we were doing was a lemon surgery, which is not any kind of a specific surgery, but it's been used mainly for laparoscopic surgery. Also have been tried for other type of surgeries, but in our center, we first developed robots that are specific for an application. That's one of the lines of investigation that we do here in the center. And as I was mentioning during the presentation, there are different ways in which we are working with this DVRK by trying to make procedure autonomous, try to teach the robot, this robot that we saw, which place to go and which place not to go to not damage healthy tissue. Try to modify the tool with new material and compliant material. And so those, we think, are the lines of in which research should be going. No, so I was saying, well, it started for laparoscopic surgery, but the robot has been used for many different procedures. For instance, cardiovascular surgery as well. But in this type of procedure, and I mean like cardiac surgery, for instance, you have other problems. So you can imagine, like, if the well, you have problems like minimal invasive surgery is more risky, right? And for instance, if the aorta start bleeding, sometimes what the surgeon does is just to place the finger right until they solve the problem. With this type of robot, those procedures are not that affordable. No, it shouldn't cause any safety problems. The robot is using traditional laparoscopic tools, so if anything would happen with robot, that it shouldn't, and it wouldn't, but if it happens, this tool can easily be removed, and the surgeon could continue the procedure with traditional tools, or just open and do open surgery. Just, I want to mention that I'm not a surgeon, just an engineer. So if there are any inaccuracies in my answer, I apologize for that. Yeah, of course. Like, it's totally possible that one day robots will be autonomous, and as I was saying, this is what we are working for, right? We would like this robot to be autonomous in the future, but the reality is that we are very far from that point. We're getting some great results, very exciting, but when it comes to surgery, you cannot have something that works half of the time, right? And if you think, for instance, of these robots that sometimes we have at home, this Roomba that cleans the floor, sometimes they make it wrong, right? And they go to the wrong corner, or like they don't clean as good as they should, right? So, of course, most of the time they do it properly, but not 100%. And that's not something that we can accept in surgery. So we need very robust system. And to get to that point, there is still a long way to go. So if someone with interest in this is watching, would encourage them to pursue a career in this field, because there is a lot of work and a lot of things to be done in the next years. Yes and no. Like everything, like everything in life, I think communication is a skill to be learned, right? And it's true that communicating with your peers or your equals, right, is easier than communicating with someone with a different background. But once that you develop the skill, I think it's something that goes smoothly, and the results start coming. Yeah, about the tools. Right now, we are using research equipment, so we use this equipment many times. But when it comes to surgery, these tools are used for many trials. Specifically, each tool can be used for up to 10 trials. Well, I think that's a very good question. I think you need to be very motivated and passionate about robotics as we are. At the end, it's true that we are trying to solve something that is very highly complicated and very important. When it comes to health, everything takes another color. But at the end, we're working with robots, which is something very cool, right? So if you're excited about it, you will find your opportunity in robotics. And about what to study, we are from very different backgrounds. Like in my case, I'm a mechanical engineer, but we have computer scientists, we have bioengineers, and of course there are a lot of doctors working with us, because of course this is a mechanical system, right? But the views of the surgeon are very important, and they sometimes can come up with very good ideas. So the answer to that is yes. There are. I don't have the numbers of how many of these robots are used in the UK, but yeah, they are definitely used in the UK, and they have been used for some years now. So Christine is asking how robotic-assisted surgery is different than laparoscopy. Well, they have some similarities and some differences, and I think some of them we have outlined them today. So the tools are pretty much the same as the one in this robot, with differences, of course, but very similar. But a robotic assisted system has some of the advantages that we've been talking about. And one that we haven't mentioned, but for me is one of the coolest, is like when Sen is moving. Well, if you think a surgeon that is moving this laparoscopic tool, we all have some inherent tremor in our hand, right? So the tool will be trembling a bit, even if you're a super amazing, experienced surgeon. But when it comes to robotic assisted surgery, we can use control and different control approaches to remove this tremor. And so even that the hands of the surgeon may tremble a bit, that will not be seen in the tool, that will smoothly run and without seeing this tremor. So that would be one of the differences between both of them. I think this is a good question. So Pillada is asking, how long should a surgeon practice on this robot to be ready to operate on a real patient? This depends on it usually depends on the degree of expertise of the surgeon. So, and I think it's applicable to other disciplines, but when we go to very experienced surgeons that they know how to operate without robots, and they are very proficient at it, they find it the learning curve might be a bit steeper. For younger surgeons that have been born with video games and that they are not so used to do this procedure manually, the learning curve is less steep. Yeah, of course. So Florent Chesefin is asking if the surgeon could be located in the moon. And so actually these robots were developed for that, to be able to operate from Earth, people in the International Space Station or in another planet. But there is a small issue with all of that, which is that both systems have to communicate in real time. And when the robot goes to, so when there is such a huge distance between both systems, there is a delay, and that delay is critical for surgical procedures. So the question is that at least nowadays, it wouldn't. So the answer would be no, at least not these days. So Alia is asking if they ask for patient consent prior to undergoing robotic surgery. Unfortunately, I don't have the answer for these questions. I understand that for any surgical procedure, the patient is asked for consent. I don't know if it is a different type of consent for a robotic system, or if you would be given the chance of a different type of surgery. I'm sorry for that. Well, I think it depends on the person, right? On the interest and what do you want to do. In my case, the differentiating factor with other things, with other type of robotics, is the interaction with clinicians and the being able to develop something alongside clinicians. I think those conversations are usually very, very interesting and fruitful, and for me is that key factor that make it different from other robotics, robotic fields. So we have a question from Mohammed Abdelaziz asking if it's possible to make this robot cheaper. Yeah, I think it's possible to make them, but so far, this is or up to at least last year, this was the only I'm on the way. This was the only big robot out there. So without competition, it makes it more difficult to have something cheaper or to make the prices of this robot to drop. So it's like another key factor to start to keep doing the work we do to get more robot out there and to make it cheaper. Yep. Sen and Sejana are informing that the lemon is fine. We have a bit of trouble with round 2 with the lemon, I mean, but he finally survived. So I think we can confirm that the 4 lemons have survived today. Thanks a lot for listening, and yep, thank you.